So we have the connecting and disconnecting fake events done now. All that's really left is while it's connected, we want to query the name of the device, perhaps change the text underneath the name as perhaps some status text, and then start reading some live data. After that, we just need to have the buttons change mode and the data then update with the UI. So let's just start with these two things, the title, and we're going to change this to status. And obviously the status is going to have to either wrap or just have a tooltip hover and have a limit on it. But for now, let's just bind these two to properties and update them. So in the dummy multimeter service, we want some more properties. We have here the properties that are exposed. So we want to expose two more. And we probably just want to say title or device name and just a general status, I think. And all we're going to do is we're going to have an event that just says title or status change. And it's not going to pass anything in, it's going to then expect you to just read it back. And then what we can do is once we've connected, so we'll simulate a connection here, run in on connected, we do this, and then we want to query technically. After we've connected, we want to query for the name. It will be a separate command. So what we will do is we can either do it in the connected, so every time we connect, we attempt to do that, which I think we will. So we'll do it here, and we'll say fetch device name. I mean, it's just a fire and forget. That will be a new method in here. We will do a try and a catch, and if something goes wrong, we will update the status. So status equals, and we probably want to say, I don't know whether we want like an error in red. I'm not too fussed about an error in red. We'll just have the text for now. So the status can then be error plus the error message. And we can say status title or status changed. And we need to actually make the fire event for that. So control dot, it's not going to give us the option to automatically do that. So we'll have to copy and paste it. And then we'll fire this title and status changed. And we don't need to do anything else. And then in here, what we can do is set the actual title. So this will be, have we actually got something called titus? No, device name, sorry, not title. Device name, and then that's actually wrong then. That's device name or status changed. Device name equals, and then we'll call this, in this case, we've got the Regal DM3068. And we can obviously test throw here. If we want to check that the exception works. So that will do that. We now need in the main view model a property to bind to. So copy and paste this one. This will be device name. And it will just say in here, no device. And then we'll probably, when we disable, we'll reset that as well. So disconnected is enabled. So I think when we disable it, we're just going to change the title ourselves. Or do we just leave it as the last one? If it's enabled, I'll tell you what, when we go to reconnect, we will just set the device name here equals no device. This will be device status. That can be blank. We'll reset the device status here. And then I'm just trying to think when we disable, this is a point where we'll probably blank these out. So we'll do connecting status is that. We could probably say, well, let's just leave it as that, yeah. That one's blank. So in fact, when it's enabled or disabled, so when the status changes, we want to update these two regardless, because it's going to change either way. and then basically if we are enabled, we're connecting, otherwise we just do that. We could do disconnecting, to be honest, like that. And that makes sense for the device name and status. We then hook into the new event, so we'll do same here. Device name or status changed, and then we'll just update them here. So device name equals multimeter.device name, device status equals multimeter.status. So I think that should work. And we need to bind to the view, obviously. So now in here where we have Regal, this now wants to be binding to device name, and this wants to be binding to device status. And the thing is, that is obviously can be too long, so we've got to bear that in mind. For the status, it's going to be way too long and go over, so we probably want to put in there the tooltip tooltip.tip equals binding the same thing, device status. So we could do a device status short, which I think we might as well just do because we know we need it. And device status public string device status short is just going to be the device status dot substring or question mark dot substring to be safe 0 and math dot min. We either want it to be, I don't know, let's say 20 characters long to start with, or the device status question mark dot length. And if it's that, then that's 0. And then this wants to be notify property changed for name of device status short. And now we have a short device name. From that, that is now telling us that device status apparently can never be null, which I guess it shouldn't, so we shouldn't check against it. This can then be shorthanded to dot dot and then the length like so. So now the text underneath should be the shorthand, and that shouldn't say disconnecting. So we've introduced a bug already. So this is device status changed if enabled. Right. If it's not enabled, are we disconnecting? Only if we were enabled. So let's just actually remove that then, because I can't be bothered to basically write the logic for handling that case. Right. So turn on connecting, and when we connect, we then get the name. There's no status. Disconnect, it goes back to no device. So in here now, once we fetch the name, we'll set the status. So we'll just do status equals connected successfully, or we could just say device alive and well, just something like that for now. And then we'll check the length of the string as well. Turn on connecting, connected device alive and well, and you can see it's cut off at the al, so it's obviously we can fit way more characters in. So let's change that limit, and let's just do well, in fact we'll throw an error to show the longer one, but let's see how much we can fit in first. So the 20 probably wants to be 50. Turn on. Yeah, so that's about where it was. So 20 was there, 40, so probably 50 is right. And now let's, instead of doing that, let's throw new argument exception, and then we'll throw it as an error like that. That should catch here, output the error into here. So error, device alive and well. Oh, of course, so the error is just a simple message. Let's do a stack trace, just so it's nice and long. There we go. So error at stream, dummy, and you can see that's actually gone too far. So 50 is a little bit too much. Probably 45 then. There we go. You can hover over and see the full details in there. So that'll do for a nice little status. Next we want these. So we want to bind properties to, we'll call it the mode title, or we'll just call it, we'll call it mode title, live value, and then we'll call this, we'll just call this symbol top, symbol bottom. So in here, we are going to want mode title, value, symbol top, symbol bottom. So mode title, we'll just do them all blank, or we could do ... dots for now. We can come up with some nice blank values. We'll have live value. I'm just going to put some zeros in. Or, well, zeros aren't really values, so dash, dot, dash, dash, dash to kind of symbolize nothing in. Maybe mode select, or we could even put not connected. And again, these, we can worry about like changing these after it's enabled and disabled. At some point, like doing defaults. And then this one we wanted symbol top, symbol bottom. And I think that was it. So symbol top and symbol bottom. Again, dash. In fact, if we leave them blank, it will shrink, I think. And we're going to have to do some logic as to whether that's visible. So we'll have to have a public boolean symbols visible. That will be symbol top string dot is null or empty, and string dot is null or empty symbol bottom. So if both of them are empty, we get that. Notify property changed for symbols visible. Oh yeah, name of symbols visible. That can go there. So if either of them to change, it updates this property. Now we can bind to that for where we have DC, which is here. This can have visible binding to that property. This can be binding to symbol top, which if we compile, that should show as it disappears. There we go. And when we bind to symbol bottom, that should actually disappear, because they will be, in fact, it should have already disappeared, because there is no symbol. So if that was false, so it's not disappearing, why not when it is blank? So that is null or empty, that is null or empty. Oh, it's inverted, so you want not, it's the opposite logic. There we go, so that's now invisible, but if we set anything, then it will show. The multimeter is here, that can be binding to mode title. There we go, not connected, and the value can actually be bound to the live value. So that's now the default nothing's connected. In here we need the same things, so we need public string live value get set, and that can be a string because it could be anything, not just obviously numbers. I don't know how it keeps doing gets and get. Live value, mode title, symbol top, symbol bottom. And what I'm going to do is probably just, to be honest, this one, I'm just going to say data changed. because we'll just fire this for when everything's changed. We don't really care about it being one thing. We'll just fire it off when we want it to do an update. We could technically just fire that off every 200 milliseconds, but if values haven't changed, in fact, yeah, that's probably what we're going to do, because values will change if we are connected. So yeah, we'll get to that in a minute anyway. This will go all the way through. We don't want that throwing anymore. We want that to be normal. And what else do we want now? We've got the values, so they won't be there. Once we're connected, we want to, I guess, get the live value. We might as well just constantly check the mode and update the text, or that can be done when we change modes. So these three are when we change modes. So we're going to say we need a mode change function. So we'll have public void change mode. We're going to need an enum in order to change to specific modes. Chuck an enum up here, public enum, and we'll call this a multimeter mode. There we go. Unknown, just because I usually do that. And then we've got all the modes now. So this is where we want voltage DC, voltage AC. We can go modes across and down, or we can go up and down. Doesn't really matter the order. Current DC, current AC, resistance, capacitance, diode, continuity, frequency, and temperature. I think that's all of them. So that'll be all the modes. We can have change mode here, having multimeter mode, and then this will update. For now, all this is going to do is update the titles. We'll have to do the calls after. So we will do, what do we want to do? I think we can do a kind of switch somehow. Switch mode, mode dot voltage DC. Yeah, to be honest, let's just do an if statement. Can't be bothered with the switch at the minute. If mode equals voltage DC. And we could do, in fact, we probably, I know this looks a bit messy, but let's just do mode title equals mode switch. There we go, that's how we want to do it. I can never remember the syntax of the new switch. Is it that? Mode switch, something like that. Or would you just remove that? Yeah, that's it. And then remove that maybe? No, that stays on. Mode switch, and then that's it. Multimeter, voltage DC. There we go. Now we can return voltage. We just want to say voltage, I think. Yeah, because there's a point. Yeah, and then we have to switch on the other. So let's just ignore that for now. What's that telling us we can do? Add missing arms. There we go. So unknown, we can literally just say unknown, voltage again, and I think you can just do here that, or that. There we go, that's a more combined one. Unknown's unknown, current AC or current DC or AC is current, and we want to probably uppercase them, but we'll do that, I think, in the style. Like when we get this info back, we'll uppercase it in the view model. That's resistance. That's capacitance. This is diode. And we could pretty much use the names, but for how easy it is, we'll just do it this way. Temperature. And for now, we'll leave the throw in. Well, we don't want to throw. There's no need to throw. We'll just do another unknown if it is unknown. That's the same we then want for the, what did we call them? Symbol top and symbol bottom. So symbol top for voltage is a V. Unknown is blank. Current is going to be, Should we do an I or an A? No, we'll do an A for the amps, obviously. Resistance is all, but we're going to have that as part of the thing. So that's going to be blank capacitance, blank diode, blank continuity, blank frequency. I can't think of anything we want. I think we just want volts and amps at the minute for them. Temperature will probably be like Celsius if that's what we're recording back. But again, let's leave them blank. So we only really want the V and the A for that. And then in here, the bottom, the only ones that are going to be is voltage DC is going to be DC, whereas AC is going to be AC. Unknown kind of wants to be at the bottom as well. That's not really where I'd want to see it. There we go. And then this one, same again. Delete that. DC. In fact, I could have just done this. Or current DC. Or current AC. There we go. So that's the 3 titles set when we change mode. There's nothing else we're going to do in this case for now. Except we want to store the mode. So we actually do want to keep a reference of what mode we're in. Public multimeter mode, get set, and we're going to default to DC. In fact, we're going to start with unknown. And when it initially gets newed up, we're going to just set it to multimeter mode equals voltage DC. So we're just going to do that. Or we're going to even call change mode, actually. Change mode. Voltage DC. There we go. Set default mode, and in fact, you kind of can't change mode until we're connected. So what we'll do is when it connects, we're going to just default to voltage DC, regardless of what anything happens. So connect, blah, blah, blah. If we do manage to connect, we're going to say unconnected, change mode, fetch device name. That probably wants to come before. And then set default mode. So I think that's where we want it. Device name's fine, disconnected. So initially, it should then pull all those values in. We then want to call, after all that, we need to do this data changed. So after we've changed mode, we will update the UI. Data changed will come into here. And then in this data change, we now need to update all the other things. So we've got the symbol top equals multimeter top, symbol bottom equals multimeter bottom, mode title equals mode title, live value equals live value. I think that was everything. So let's see where that gets us. So they're all off. We turn on, should connect, shows connected, shows voltage, which we need to uppercase, shows the voltage and the DC, but the value is currently blank, which technically is valid. It could be nothing, but looks strange. So let's do the mode title can be, it should never be null because we haven't made the string nullable. So we'll just do dot to upper. The live value, symbol top and bottom, same thing, to upper. Device name and status can stay the same. In fact, I want the device to upper as well. The only one that isn't is the status. The live value, though, let's actually put in a live value. So we've done change mode. We connect. Once we're connected, where we'll do the live value now is, because this is kind of a real application in a sense, we want to now do here. So if connected, get live value. So if is connected, I think that's all we need to check. If it's connected, I guess, and enabled, for good measure, fetch live value. And then we can just go to here, public void fetch live value. Same thing, we'll want to update this, and this is now going to update every 5 times a second, basically. So let's do something cool here. Let's store let's store a counter. So for or private float live value test equals 0. And then what we will do is all the way through, when we disconnect, we'll reset this. So let's just do on disconnected live value test equals 0, reset it. And then in here, we will just do live value test plus equals 0.2, I guess. No, 0.05, something like that. And why is that a problem? There we go. And then let's just update the live value with underscore live value test dot to string. So that's now just going to cause a random constant updating value as soon as we connect, if it's working. There we go. And you can see that is updating. We probably want to limit the value because we don't really want to see all them digits. So we will do math.round three decimal places to string. And that didn't seem like it was updating 5 times a second, to be honest. It seems slower. No, it probably is. Just seems a little bit slow. Let's make that faster. I just want to see it updating nice and fast. Oh, see, that's quite... Because this could be real. This could be how it's changing. So we want to actually make sure this is... How can we fill it with zeros? We want to do a string format, actually. We just use string format instead of that. So a much easier way is to use the built-in string format, which I think there's another way of doing that as well. We can do this, like so, and then is it colon? There we go. And we can do 0.000 to force. In this case, obviously, we're expecting this value at the minute to be a number. This is just a test, but that's something that we're probably going to display. This should now be a fixed width all the time. There we go. So that looks a lot more easy to see. Obviously, you've got the slight movement due to the font. It's not a mono width font, so we might want to change it to a mono width, but I'm quite happy with that. So that simulates the voltage change now. I think next up we can either do the styling of this border, like the colours, because I want to change the colour of this border based on the mode. I also want to change the colour of the border based on the values, so they want to change. So let's bind the values of this text and border, and let's make this change as we scale up the voltage. So for that we need another value, and this will be public. It's going to be a iBrush, and this will be I guess, what shall we call it, border color, and this can be a new solid color brush dot, where's the new color brush we did? Why is it not showing me? Colors.green. So this wants to be color.yellow. In this case, we'll just default it. We'll default it to white, actually. And we'll do live value color can be white as well. And then same thing when we connect in modes, we now want to change them here. So we'll copy the first one with all the options. And we will do, and I think, depends on the threads, we'll see if this works. We want border color, mode switch, voltage AC or DC. We want new solid color brush, yellow. So we'll do a yellow brush for that. Current, we wanted the, it wants to match the buttons basically that we've got all in here. So current wants to be medium purple. And then we'll do the same for all these. And to be honest, I haven't finished setting these yet, but we don't want two colours. We just want a... I think we just want to call it the colour, to be honest, because we're never going to change the border different than the text thinking about it. So we'll just call this colour. It saves us doing more work as well. And now I need to match all these up. So that's now all of them in. I've even added the linear gradient brushes to match the buttons as well. So that should now set a single colour that we can now bind to. When we do that data changed, we'll do the colour update as well. So back in here, data changed, we need now one for the colour. So we don't have it in this side of things. We will want, probably put it by the symbol somewhere here. Private iBrush, and this can be the multimeter colour, we'll call it. And this can be a new solid colour brush, white by default. Multimeter colour then we can set when we get values here. So multimeter colour equals multimeter dot colour. And we didn't expose it correctly then. I thought we did. Public brush colour. Oh, multimeter colour. Multimeter service dot colour. There we go. And then finally bind the actual colour. So we should have yellow floating around somewhere. Border brush. This now can be binding to, what did we call it? Multimeter colour. There we go. And the other yellow is there. There we go, it's then now white, and presumably we're now in control. And I think we set it so obviously it will pick up yellow. No. Well, yes and no, maybe. We'll see. Did we actually set the colour anywhere? So we did change mode. Change mode changes the colour, and we know we've called that. So colour gets set. Yes, that should have worked. So multimeter colour. We'll just check obviously when we change this. Multimeter colour is a solid colour brush. It'd be nice if it showed me what it was. Colour, calculating a portion, not going to be able to. It's going to be something to do with threads again. Probably that we can't, well, we're not creating. So we hit here, the mode is voltage DC. Voltage AC and DC is that. Oh, is that crashing then? Yeah, so that's actually crashing. So the same thing. We can't construct. It's kind of a pain. We can't construct the colours. These, because they are UI elements, we can't construct the brush in this way, like on this thread. So it has to be on a UI thread, which is kind of a problem because we want to be able to do the gradients. I mean, I'm not too fussed about the gradients, but they are going to be nice. But we don't want to spin off on a UI thread every time we want these colours. So I think what we'll do is we're going to have to store every one of these colours as a static thing that we already have. Or we can move this colour logic. One easy way is to move this colour logic to another thread, but let's just do this for now. Colour yellow, or we'll just say colour voltage. I'll do it for one because that's the only one we're going to hit. Check this works. Private iBrush colour voltage equals new, and I presume this will work fine because this is getting constructed on the UI thread, so this will get constructed at the right time. And then the colour voltage will return here, so I don't think that should crash, and we should get the colour updated. Yep, there we go. So we just need to, bit hackish, but we'll move these all out now and do colour current, and then I'm going to do the same for all these. And there we go. So we've got all of them now keyed off to properties. Up here we now have the properties made that get made in the constructor when it is on the UI thread. And I've put everything in regions now, so we have a bit more of collapsible items basically. These can all be read-only correctly, so Make all them read-only. And now that should mean the modes all work. So let's do a mode change randomly for now, just every, I don't know, every second or something. So if we go to the constructor, we're in this while loop. That's now updating tons. So if we just say var I equals 0, we'll go somewhere here, I plus plus. If this is just again test code, if I is greater than, so if we have 20 of them, then it's roughly a second. We'll do increment mode. We'll just make a little helper function that will increment the current mode. So we have change mode, our public void increment mode, and all it'll do is take the current mode plus plus, so you can just do that on an enum. I don't know whether that's going to automatically wrap, we'll soon find out. And then you just do change mode. Or in fact, you can just do change mode, mode plus plus. And then it's just whether that enum's going to wrap or whether it's going to auto. But for a quick test code, that should work. So every second, it's going to call change mode, sorry. And then hopefully we'll see the color change of the outline and the title and everything else. Oh, that's actually running when it's not connected. So that was running crazy fast. Oh yeah, and that's because we also didn't reset that. So I equals 0. And we also want to say it's only if it's connected and enabled. We want to run this test code. So there we go. So turn on, and then presumably every 1 second, that's going to change. Unknown voltage, unknown current. Okay, so the plus plus is a bit strange, but it's going through the modes, continuity, frequency, temperature. Oh, I like them gradients. Yeah, so we're getting some funky stuff with just the fact we're randomly adding numbers, but you can see the modes cycled there. So if we turn off, turn on, voltage, unknown, which for some reason, I don't know why. We could have a look at why, but I'm not 100% sure what comes through on here. So the mode is voltage DC, which is obviously an integer. Then the mode is 20. So why when we add 1 to 1, we get 20, I'm unsure. It's a bit strange. Then after that, we get 21. So yeah, the mode plus plus is a bit bizarre. Maybe we just have to force mode to an integer and then add it and then cast it back to a mode. We've just been super lazy in terms of figuring out this way of doing it. I don't know. That will have to be multimeter mode. See if that does anything different. But the idea is we've seen them change, so we just get the buttons to do it next. So voltage DC, voltage DC again, voltage DC again. So it's not doing. Oh, multimeter mode is unknown apparently. Do we not? Oh, we don't actually save the mode. So this should actually do mode equals mode first to change the mode. And that looks like it's now going to work. So maybe that was a bit of the strange quirkiness. Turn on. Voltage. Current. There we go. Resistance. Capacitance. Diode. Continuity. Frequency. Temp. Unknown. And then I don't think it wraps. It'll just carry on counting. So it doesn't wrap anyway. But that should just mean all that wasn't needed. And you should just be able to do change mode, mode plus 1. Yep, so that's fine. And I think they all match the colors, which they do. And actually, you know what I've just noticed? Do we actually have the voltage AC and DC? Yeah, we do. So voltage, oh yeah, voltage AC, then DC, then A. Yeah, I didn't even notice that changing. So that's all working great. So now the only thing left is if we turn off, we could, reset these, disable that and send it back. But for now, again, we'll leave the small bits till the end, like the resetting of them values. Or should we just do it now? No, let's just do that bit now, and then we can wrap up. And the last step is clicking these to change the modes instead of it being automatic. And we're ready to integrate with the real backend code, and this is done. This is a fully working product then. So the dummy code's simulating what should happen, and this is what we want to see. So let's just clear. We want to clear these 4 back to defaults, and we want to set, we'll remove this now, the code on here, and we'll keep that one active. So we'll have the temperature class active, that can go now. And then in the disconnect, where did we reset? We kind of need a reset position in here. Data change, disconnected. It's not necessarily a disconnect. We don't care about that. It's when we turn off here. So see, if we turned off, do that, it's really if it's not enabled. So this is where we can't presume we are disconnecting, but we can presume we're not connected at all, like we're not enabled. So this wants to be the set default place, basically. As this is where all the default values want to be. This one is the case that either disconnecting or connecting, whenever the status changes, we want to reset. So I guess, does that mean either way? I think, again, either way, we want this to be the case. So it doesn't matter whether we're enabling or disabling. This is where you want to reset the values. So we'll have the live value equals, and then really, you can kind of almost leave them here, but they're just doubles of these. So we'll just do the live value equals this. The symbol top equals symbol bottom equals device status equals blank. So that's the symbol top bottom, the live. We have the mode title as not connected. There we go. Live value done, symbol top and bottom done. Multimeter color probably wants to go back to white, but again, I'm quite happy leaving that as the last mode, because otherwise you can't reconstruct these colors. But we could just do a default, unknown mode brush. We could just do, and then we can reset the color brush. Otherwise, that becomes difficult to reset. So multimeter color equals unknown mode brush. Device status gets, we don't reset that, we just do there. So again, device status equals, and then what is it normally? Is it just blank? I think it is. So I think that's every value. Let's just run it and see. And when we disable, it should turn off. So we've got not connected, all blanks and dots, no device, all blanks and dots. So if we turn on, stuff starts happening. We turn off, there we go, everything goes back to default. And then I guess one last thing as well, we don't want to be able to change this while this is enabled. So we want to just tie that with the enabled to the is enabled toggle. Do we need that name now? Yes, so we can bind it like this, and we can do a not on it. So is enabled equals binding to checked, and we want it to be converter. So we're going to have to do a converter is it a static? I always forget this. X colon static object converters dot not equal, is it? Is that it? So I can type in turn on, no, is it bull? Is enabled, is checked, converter. Let's just do the opposite. So just to check this is working. Oh no, is it a bool converters. There you go. Bool converters not. Is that it? I'm sure you can just put an exclamation mark, but yeah, there you go. So you enable, you can't change this, it's all running, turn off, you can edit this. Perfect. So literally the only thing left is, oh, one last thing actually. I wanted to do something cool on these modes. I'll add all these modes after, but one thing I wanted to do, if we don't change the mode, so if we don't do the increment mode, what I wanted to do was, based on the live value in, say, like the voltage and things, I wanted to change the color. So this would be, say, for example, voltage AC, voltage DC, color gradients. So we'd say, in this case, it's for every mode, but that's what I want it to be. So we'd say if the live value test is, for example, less than 1 volt, then we want the color. So in this case, our color to equal the unknown color, which is white. I'll say if line test color is greater than 1, or in this case, if it's less than 3.5 volts, then color wants to be, and in this case, we want it to be a different color. I want it to gradiate from like I think you want to be yellow for this, orange, so we'll just nick the diode for above that. And you'll see what this will do. It's like a nice visual on screen very easily for what the voltage is, so you kind of get a quick idea. Also, if the live voltage is less than, say, 6 volts, then color will equal the orange. Else, that means it's greater than all that. The color wants to be red. So we'd probably do the temperature one as a cool burny color. So color temperature. So we can do all kinds of stuff like this. Now we're in control of the data. A multimeter couldn't do this, but we can do it because we're in complete control of literally reading the data and then doing something with the UI based on that. So now, as this voltage grows, you should see the color change. So white, and it goes to yellow. So this would be real. If you're measuring voltage, it's going to then go to orange, and above 6, it's going to go to hot, which is a high voltage. So how cool is that? We've now got a changeable color. As I'm probing in real life and measuring voltages, I can have a very quick visual indicator of how high the voltage is without even reading the number. Plus, if I then see something in red and burny, I know for a fact it's above a certain value, so I don't accidentally read the value wrong. It's just another feedback and hint. So that's really nice. So yeah, that's all fully running. The literal only thing we've got left to do is when you click these buttons, we want to call change mode and the specific mode, which is not hard at all. And then we integrate the real backend code to talk to the real multimeter, and we're done.